Alright, so welcome back to another video on Node.js, and particularly on sockets. So this is one of the fundamentals of the internet and a topic that really excites me. So imagine that you're building a chat application with the thing that you already know, right? So you have the HTTP post to send message and get to read all the message. The question is that from the client perspective, when do we know or how sorry, how do we know when to fetch data on the server? So data that is outside of our control, that because we're building a chat application, data that we didn't create, for example, when we send message to our friend or family, or data that might be in their own life cycle. So usually we deal with this kind of situation with a, quite frankly, very effective approach, polling. So we send requests so often, we send get requests so often to the server in a particular time, and when that time has passed, we send a new get request in a loop essentially. So looking at this pseudocode, when you are using, for example, set interval to send or to particularly to fetch data message from the server, we adding here is a pull rate, so 500 milliseconds. But there is an issue with this approach because when is the right time? When is the right period of time to fetch data? Another question is there even a right period to do that? Doesn't it depend on how often the data change on the backend? So for applications like chat app, adding 500 milliseconds, it will add 500 millisecond delay to all of the updates, right? So if you send a message, so your friend will receive that 500 millisecond after you send that, plus all the latency in the network. Okay, so for chat applications might be okay to go with, but what about the real stuff? Things that need real-time interaction, such as self-driving car, stock trading, or games. And also, let's go to let's go to, even though take this approach. So we're making is one request per 500 millisecond, two requests per second, 120 requests per minute, and this is just for one single user. So imagine that you have 10,000 users. You have WhatsApp, Discord, Telegram, Signal. So you need a very powerful server or a collection of powerful servers, or a different approach. So sockets come to the rescue here. So first I look at understand what is the concept of socket, which is this is an opening or a holder that form a holder for something. So for example, electrical bulb socket or the eye sockets, but in the context of computer systems and network computers, so a data socket is an opening in a computer system. And just to refresh about what a computer means, is a programmable machine that performs arithmetic and logic operations automatically, and a system is this computer, this machine made of hardware, software. The most relevant software is the OS, and it is peripheral. So in desktop you have is the speaker, keyboard, mouse, monitor, right? And in a laptop, everything comes built in, which is great. And that's the reason why it is so expensive. So that's what is this socket. That socket is an opening in this computer system uh, that in which you can connect to send and receive data. So the data holder or this data socket is a holder of this type of connections in a network computer. So network computer is a set of computers that share research, much like, for example, people in a particular state, okay, in a particular community where they share things, literature, knowledge, culture, music, insults, fluid, you name it, they exchange that. But now, as a computer, they're just exchange or share research provided by a physical location, such as people in a particular community, or provided by network node, either a redistribution point, okay, such as a BGP, which means is a person that acts as a spokesperson for something, a government, a company, or a family member, okay. So this network node can be a redistribution point, such as this BGP, broadcast border gateway protocol. That is a protocol that exchange, or you can think of that as a language, okay, that exchange routing traffic between different autonomous systems. So these autonomous systems are interconnected network that operate under a single admin domain. And we can think of this autonomous system much like the community close to you that is ruled by the municipal law, for example, or the state law, right? So much like these autonomous systems. Again, they are interconnected networks that each cluster may provide, for example, in the context of Google, a cluster can handle is the Google Maps. Another cluster is the uh, Google Docs, Google Spreadsheets, and so on and so forth, right? So this network node can be either a redistribution point or a communication endpoint, an address to identify a communicational entity or communication entity, such as an application, uh, a service like a server, a desktop or laptop, a router, switch, a firewall gateway. So understand that and being able to mention, to talk to others, particularly here, I'm just talking to the camera, but to be able to mention, describe that is something powerful, interesting, that with that fundamentals, all right, of the computer system and the computer networks, and understand is the concept like computers, computer systems, and network nodes with distribution points and or communication of entity, autonomous systems. Uh, so this exchange of data of communication is what the internet is based on, right? And the basic building block is the IP socket. And on top of that, you have this diagram where low latency is the most important factor. Let me one second here. Okay. Yes, so where low latency is the most important factor. You also have this TCP connection where it's reliable, so you know when you send a message if that message was received or not, and it's connection based. So before sending a message or receiving, you need to connect. And on top of the TCP socket, we have is the web socket, where this allows two-way communication between the user browser and the server. This protocol. And web developers and backend developers must know that. This is a JavaScript feature that allows these two ongoing conversations to happen. And then you have HTTP, which follow the health duplex. So before you, so it's based on like a walkie-talkie. So you have to listen first before respond, right? Uh, so knowing that, all right, and how is this made of this network socket, which in WebSocket, that's the real power, okay? And the beauty of this is that, for example, in HTTP, you have to send a request to get a response, right? Whereas on these WebSockets, you can have these real-time communications to happen. Okay, so now I look at the difference between socket and polling and how polling use the HTTP protocol to mimic this two-way communication behavior. Of course, with a huge trade-off because now you are flooding this server with incoming requests. Whereas with sockets, we already have this channel between the browser, the user browser, and the web server that allow this real-time communication. I also looked at implementation of that. Okay, it was pretty interesting and powerful as well. So this is revolutionary in WebSocket because now it's a server who is responsible to keep up the client up to date. We don't need from the client figuring out when to send data, or we don't need to guess when to fetch data. So with WebSockets, this approach of to make this real-time communication is a very good use case for centralized networks, right? But for distributed networks, right, where now is the client is also act as a server, that might be a different approach. Okay. In any case, it's important to recognize that. So then I look at the WebSocket, uh, which is much like in the HTTP, which is the protocol where you have several implementation of how to fetch data from the server, such as Axios or NoFetch. In WebSocket, we have WS. This only works on Node, but if you want to make that, or if you want to work with that library, you can use some non-popular package or rely on WebSocket directly. So WS in WebSocket, for example, WS handles or exposes a different API as the WebSocket. And for example, if your browser doesn't support WebSocket, you are not able to use it. So you're not able to create this channel. Even though there's a package a top-level package and convenient that provide socket or web sockets in both ends, the client and the server, providing fallbacks in case the browser doesn't support it, or in case the browser doesn't support WebSocket, and that is Socket.io. Socket.io is a very extremely popular library that makes it easy to use it uh, using the same interface to using almost or using the same interface for the client and the server with its own particularities, providing fallbacks. And that's something crucial when you look at the socket.io and why we use this, because this allows real-time communication bi-directional event-based that works on every platform. So we don't have to worry about compatibility issues. So there's some professionals like Microsoft Office and Trello that use that and understand the architecture of the WebSocket and how it's made of. So you have this a client and the server, but both of them uh, they share the same API. So here with Socket.io, you don't need to juggle in between two different APIs with two different set of functionality. You can stay focused on write the code of your app, and also allow us to save brain power for creating new functionality as opposed to hunting bugs. And this is something important. So it also saves us brain power for creating new features as opposed to hunt bugs and worry about compatibilities, right? And that doesn't mean that you won't have bugs, but if you can minimize 10 or 20% of them, we can save a lot of time. And another perk looking at the socket.io is not only that we don't have to juggle in between two different APIs and two different set of functionality, so we can focus on writing for applications, and also we save a lot of brain power because it save we can save a lot of brain power uh, as opposed to hunting bugs or worry about compatibilities. Again, you still have bugs. Again, you still have bugs, but if we can minimize 10 to 20%, we can save a lot of time. And there's another perk which is important when building large-scale application products, and that is the fallbacks. Mhm. And this perk is something important, the fallback. So when we start our chat application, for example, the client side, with the Socket.io or for this, okay. So this perk is important when building large-scale production applications, the fallbacks. So it works by when you start your chat application on the client side, the Socket IIO will try to attempt to establish a WebSocket connection first between the client and the server. And if the browser, if one of the last 3% doesn't support WebSocket, socket stick to form totally. In this way, you're guaranteed that your app works on all devices. Very important in corporate environments. So now let's take a little deeper at the implementation. Okay. So the TLDR for all of this, right, is to understand what socket is, the reason why we use socket, and especially for a particular use case of creating a chat application. Uh, Using HTTP is not ideal for that kind of application. First, we are flooding the for performance issues. Like we are flooding is a server with incoming requests, and then we need to add some latency to all of our updates in our application. Even though this is a very effective approach when using is HTTP protocol. But sockets, we don't need that because, well, after all, it allows us this two-way communication. It's an open channel between the client and the server. So understand also what socket means. So it's also important because from this definition, I also saw the computer system, network computers, and all of the underlying content, right? Such as hardware, software, peripherals in the case of software computers, and in the computer network is um, um, network nodes uh, like uh, uh, yeah, network nodes like uh, redistribution points. So where here you have is redistribution points from different autonomous systems. What is autonomous systems? In a real example of that, and the communication endpoint, and some examples. So then I can look. Then I also look at the WebSocket. So that WebSocket, yes, allow this two-way communication between the user browsers and the web server, an implementation of that and how you can do that, and much like the HTTP that has several implementations on how to fetch data from the server, like Axios or NoFetch. WebSocket also have several implementations. But you have WS, WebSockets. The reason of not using that because WS only works on Node, WebSocket on the browser, and if you, for example, if the browser doesn't support WebSocket, you will need is so you are not able to use that. So I also look at another implementation of Socket, which is Socket.io, extremely popular, which allows this real-time, bi-directional, event-driven communication that works on all platforms. So instead of focusing on compatibility aspect or debugging, so Socket.io abstract a lot of this, specifically the compatibility aspect, and also save bring power to create features as opposed to hunt bugs, where of course you're going to have bugs, but if you're able to reduce that 10 or 20%, that saves us a lot of time. And another perk that Socket.io offer is the the fallback compatibility. So this is essentially important for corporate environments. So that's good. That's great. Okay, because I also so these fallbacks work by For example, when you start a chat app client, Socket.io first tried to attempt to connect using WebSocket, and if your browser is one of the left 3% that doesn't support that, it will stick to a form fully. Okay, so Socket.io stick to form wholly. So this way, you guarantee that your app works on all devices. Again, very important in corporate environment. So now taking a little deeper in the implementation, Socket.io client and the server API, that's exactly where we are going to. That's exactly where we are going to. Like no. And here you have a socket. Then you got it.
Welcome back. We've seen that Socket.io is composed of two parts. A server library, which will integrate with the Node.js HTTP server,
Mm-hmm. So that's right. The server, uh, so socket.io is made of two parts, client and a server.
and a JavaScript client-side library that loads on the browser side. These live in two separate GitHub repositories. We have Socket.io for the backend, and we have Socket.io client for the front end when we're using JavaScript. But even if we wanted to create a client in another language, say Java or C++, there are implementations of Socket.io which we could use to talk to our Node.js Socket.io server. So this is a very versatile library. There's even bindings for Dart and Swift. And if we scroll up here to the Learn section, we can see that there's a server API and a client API. So the functions that we'll be using aren't exactly the same.
Mm-hmm. Important thing here. Exactly, because the way how that works, and the responsibility that each one of them has. The way um, we we are going to use then here.
But API and a client API. So the functions that we'll be using aren't exactly the same.
Mm-hmm. The functions that will the function that we'll be using aren't aren't exactly the same, because the way how
But this makes sense because, as we're about to see, the client and server need to support different sets of capabilities.
mm-hmm. And this makes sense because the client and the server support different kinds of capabilities. Right.
They have different roles. Remember our chat example? With sockets, like with HTTP requests, on the client side, we always talk to the same server. We'll only ever send messages to that server. However, on the server side, sockets allow us to send messages to any one of the many clients that are connected.
Mm-hmm. The sockets allow us to send message to Anyone that is connected.
Server side, sockets allow us to send messages to anyone. Always talk to the same server. We'll only ever send messages to that server. However, on the server side,
This is on the client side. So on the client side, we'll always
sockets allow. Remember, functions that we'll be using aren't exactly the same. But this makes sense because, as we're about to see, the client and server need to support different sets of capabilities. They have different roles. Remember our chat example? With sockets, like with HTTP requests, on the client side, we always talk to the same server.
exactly. So from the chat, for the chat app example, we always talk to the same server from the client.
We'll only ever send messages to that server. However, on the server side,
However, on the server side,
sockets allow us to send messages to any one of the many clients that are connected.
So however, on the server side, socket.io particularly,
However, on the server side, sockets allow us to send
or socket, exactly. The sockets allow to send message to any connected client
messages to any one of the many clients that are connected.
allow to send message to any connected client.
So say we had another client that connected to our server, that joined the chat room. The server would be responsible for sending any updates, any new messages to the
Exactly. For example, on the chat example, is the server that is responsible to send any updates to the client, and that's crucial here.
that new client, whether it be the original hello message or a message from any other client. So our server needs to be connected to and sending messages to multiple clients at the same time. This is different. The server would be responsible for sending any updates, any new messages to that new client, whether it be the original hello message or a message from any other client. So our server needs to be connected to and sending messages to multiple clients at the same time. This is different than the HTTP requests that we've already seen, where the server will always send a response to the client that made the corresponding request as a response to that request. With sockets, the server can decide when to send messages to the client.
Exactly. With sockets, now the servers can decide when to send message to the client.
What does this difference mean for our socket API? It means that our server will need to support some additional functionality over the client. For example, by keeping track of the multiple clients that are connected to it, and by having the ability to send messages back and forth between these clients individually, or to broadcast messages to all of them at once. For example, when the server receives a new message.
So this mean? So what this mean on socket? Yeah. So what this mean?
Clients that client that made the corresponding request as a response to that request. With sockets, the server can decide when to send messages to the client. What does this difference mean for our socket API? It means that our
So this different from HTTP approach to socket.io API means that the server has different has uh, other features than other features, such as keep track clients.
server will need to support some additional functionality over the client. For example, by keeping track of the multiple clients that are connected to it.
Mm-hmm. Such as keep track of multiple connected clients.
And by having the ability to send messages back and forth between these clients individually.
Exactly. Such as keep track multiple connected clients, send message individually, or send message to a group of clients, or broadcast message to all clients.
Or to broadcast messages to all of them at once. For example, when the server receives a new message, it needs to notify all of the clients of that new message by broadcasting it.
Mhm. And that is
When to send
something
messages,
important.
additional functionality to it. And by having the ability to send messages back and forth between these clients individually, or to broadcast messages to all of them at once. For example, when the server receives a new message, it needs to notify all of the clients of that new message by
Exactly.
broadcasting it. The reason behind Socket.io's success is the excellent high-level API that it provides.
The reason Socket.io extreme extreme success is is that unified.
The reason behind Socket.io's success is the
So the reason Socket.io is extremely, or the reason behind Socket.io success is
excellent high-level API
is the excellent high level API.
that it provides for both the server and the client.
So this is the excellent high level API it provides for both for both the server, for both for both the server and the client.
In the server API, as well as in the client API, it uses the Node Event Emitter pattern, around which
Yeah. So it uses the same. for both the server and the client.
Node's core APIs are built. If we remember, with the event emitter pattern, every action that occurs in Node, like a connection being opened,
Mm-hmm. Both are based on the event emitter API from Node. So the client and the server, so both are based on the event emitter API.
or a message being sent, every one of these actions can be represented as a named event, which can be emitted using this emit function. So for example, in our socket, that occurs in Node, like a connection being opened or a message being sent, every one of these actions can be represented as a named event, which can be emitted using this emit function. So for example, in our socket, we could call the exact same corresponding emit function on our socket. And this would send a message to the client connected on that socket. However, it's also common to want to broadcast the message to all clients. For example, when the server receives a new chat message. And to the client connected on the exact same corresponding emit function on our socket. And this would send a message to the client connected on that socket. However, it's also common to want to broadcast the message to all clients. For example, when the server receives a new chat message. And there's this handy
Exactly. So overrides the event emitter emit.
emit cast the message to all clients. For example, when the server receives a new chat message. And there's this handy emit cheat sheet if we go, and this would send a message to the client connected on that socket. However, it's also common to want to broadcast the message to all clients. For example, when the server receives a new chat message. And there's this handy emit cheat sheet if we go to the documentation page and go to the emit cheat sheet here. We can see all the different ways in which we can send a message or emit a message in Socket.io. Now, don't worry, we don't need to be familiar with all of these functions. Right now, let's take a look at the most common example, which is broadcasting messages to all the clients. We can see that we have the default emit function.
Now looking at example here. This is just example. A couple examples. A couple examples. Like emit to all clients,
Where we name our
presenting to the
event
client.
and then pass some data to it. That will be sent to a single client. We also have this
Exactly.
socket.broadcast
This is sending to a single client. Sending to a single client.
.emit function, which has a
Sending to
similar
all
payload
clients,
of a
sending
named
to the
event
sender.
and some data. And we can see that this will send to all the clients except the sender. So all the clients except the one that is connected on this socket. We would use this, for example, in our chat. When we receive a message on this socket, we can then call socket.broadcast.emit and forward that message to all the clients except the one who originally sent it, because that client will already have that message. Now, in some cases, we'll want to send a message to all the connected clients, including the sender. For that, we have this io.emit function, where we send some data to all the clients that are connected to our socket server. If we compare this to the lower level WS package,
Yeah, exactly.
which works just on the server, it actually has some usage examples where it implements this higher level functionality from the functions that it provides. So if we wanted to broadcast using the WS library, we can see that
Exactly.
to broadcast to all clients, including the one we're currently receiving a message on, we would have to do several lines.
So compare. Mm-hmm. -7. All right. So compare to
functionality from the functions that it provides. So if we wanted to broadcast using the WS library, we can see that to broadcast to all clients, including the one we're currently receiving a message on, we would have to do several lines where we respond to a message and then go over a list of clients that are stored in our WebSocket server. And for each client, check if it's ready to receive data, and if so, send it the data that we just received. This would be one line in Socket.io. And we have a similar function here for broadcasting to all the clients except the one that we're receiving on. So similarly, we go over the list of clients, make sure that the client is ready, and check to make sure that the current client in our list is not the one that we're receiving on. Just with this simple example, we can see that Socket.io makes our life easier for the most common usages of WebSockets, while also allowing us to build reliable production scale applications, for example, by taking advantage of the fallbacks that we
exactly.
discussed earlier. Also allowing us to build we can see that Socket.io makes our life easier for the most common usages of WebSockets.
Exactly. This is something important. So this will be one line in Socket that I have. So this not only makes our life much more easy, but also
while also allowing us to build reliable production scale applications.
Mhm. but uh, but also allow us to build reliable exactly, but also allow us to build reliable production scale applications.
For example, by taking advantage of the fallbacks that we discussed earlier. All right.
By taking advantage of the fallback.
It's about time we got to some coding, don't you think? I'll see you in the next one.
Mhm. So with this, all right, which it was very very important. This introduction to the Socket.io, the client and the server, because
Welcome back.
Socket.io
You're
is
still here
made of
after all that.
two parts. Okay, so Socket.io is made of two parts, the client and the server. So the function we'll be using are exactly the same. This makes sense because the client and the server support different kind of capability. They have different roles. They have different roles. So from the chat app, from the chat app example, we always talk to the server from the client. Okay. So for the chat app example, we always talk to the same server from the client. However, on the server side, Socket allows to send message however, on the server side, Socket allows sending message to any connected client. For example, in the chat example, right? And the server is responsible to send any update to the client. So it's a server now on the server side, Socket sending message to any connected client. So for example, in the chat example, in the server is responsible for sending any update to the client. So the difference here, the difference from HTTP approach to Socket.io API means that the server has other features such as keep track multiple connected clients, send message to individuals, send message to a group of clients, or broadcast message to all clients, to all connected clients. And that is something important to understand. So the clients always talk to the same server, right? However, on the server side, sockets allow sending message to any connected client. So, for example, in the chat app. So the difference between the HTTP approach and the socket.io API means that the server has other capabilities, such as keep track multiple connected clients, okay, send individual so message individually, send message to a group of clients, or broadcast message to all the connected clients. So the reason behind Socket.io's success is is the excellent high-level API provided for both the client and the server, and both are based on Event Emitter API from Node.js. So when you want to emit a message or emit an event with the name of the event and some data, like this example, or for other example, like sending to all connected clients. So compared to the WS API, like this, to broadcasting to all connected clients, including itself, this will be one line in socket.io. So this not only makes our life much more easy, but also allows reliable production scale application by taking advantage of the fallback. And that is something crucial from this video. So that'll be all for this video. Take care. Bye.